To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students. So within this chapter, we'll be discussing about the constellations. Now in the earlier chapters, we discussed several things regarding to the solar system, and we identified about the planets, their distances from the sun, how does the revolution is going to occur of them, and several other information regarding the planetary system. Then after that, we studied about the eclipses, about the solar eclipses and the lunar eclipse and so on. Now within this part, we'll be studying mainly about the constellations, star patterns actually. Okay, so as you are given here, ancient people who were watching stars in the night sky imagined various star patterns by joining them. Those ancient star patterns identified earlier and those named recently are called constellations. So these star patterns were previously identified, or first of all identified by the ancient people like the Chinese people, Arabians, and also Indians and Greeks also, right? So these star patterns, okay, now when you take the star pattern, they join these star patterns. I mean, like they took several stars and they joined them by using straight lines. Then after that, those star patterns were given with a certain name according to the pattern. So after that, later on, these star patterns were named as constellations. However, those things were named as constellations in recent times, my dear children. In the earlier times, these were referred as star patterns. So there are several star patterns in our universe, right? So these things can be observed even from our naked eye without any trouble. If you watch the night sky, my dear children, you can observe these things. But however, if you take a certain type of a star pattern or else a constellation, there is a certain time period which we can observe these things. So during that time period, if you went to see and went to observe the night sky, then you can observe these star patterns, right? So here, there are 88 constellations identified so far. So up to this point, there is about 88 constellations. So up to now, we have identified about 88 constellations. So from that 88 constellations, my dear children, we'll be observing or we'll be identifying several constellations within this lesson part, and also we are discussing about several important facts regarding these constellations and their users as well, right? Then, so it is important to identify the directions when observing the stars at the night sky. Now you know that we have to observe stars at the night time period. Stars are there at the daytime period also, but however, because of the solar rays or sunlight, we can't observe stars very clearly, right? Because the brightest object if you take the brightest object during the daytime, that's the sun. So because of the sunlight, we won't be able to observe the light given out by the stars, because sun is very closer to us, even though the other stars are somewhat like at a distance. Okay, so therefore, in order to observe stars, right, we have to observe these things at a night time period. So in that case, my dear children, there is a small bit of a trouble, small bit of a issue. What is that? So we won't be able to identify the directions. That's the main issue. It's because that during the daytime we can identify the directions without any trouble, because the place or the direction where the sun is going to rise can be referred as the east direction. So the opposite direction where the sun is going to set, that's the west direction. So during daytime we can, we can get a certain clue by looking at the position of the sun. However, in the night time we won't be able to do that. So in that case you have to use either a compass, or else during daytime you can point out, or else by using a certain tall building or else a tree, certain type of a tree, you can memorize the east direction and the west direction. By that way you can find out the other directions as well. Okay, so it's important to identify the directions when you are observing these constellations during the night time. So my dear children, here it is given, check. In the daytime, directions can be found using the direction of the sunrise. Of course we can, right? So stretch your hands apart and stand facing the direction of sunrise. Then the front side is the east, back side is the west, your right hand side is the south, and the left hand side is the north. So let's imagine that. Now first of all you have to take a good clear area for this thing. Okay, because we are observing the night sky now. So you have to go to a very clear area so that you can see the whole sky without any obstacle. Okay, so after that my dear children, you have to decide the directions. So to decide the directions you can use a daytime period, morning time period. So you go to that place on a morning time period, then you face the sunrise. For the direction that the sun is going to rise, you face it like this way. So let's imagine that that's the direction which the sun is going to rise up. So I am facing that direction. So if I am facing that direction, definitely that direction is the east direction. Then my back side, the opposite side, that's the west. That's the west. Then my dear children, if this is east, if this is west, then my dear children, definitely my right hand side is going to show the south direction and my left hand side is going to show the north direction. So here the front direction or the front side is the east, the direction which you are facing, that's the east direction, right? Your face is at the east direction. Then back or the opposite side is the west, right hand side is the south, right hand side, this one is the south, and the left hand side, that's the north. That's the north. Okay, so what you have to do, I have to select a particular place first of all, right? A clear space. Then you have to identify the directions, the main 4 directions. So in order to do that, you have to visit that place during a daytime. Okay, then at the daytime what you have to do is you have to face the east direction. It is good to, or it is more probable to visit that place during a daytime, a morning time period, so that you can select the east direction without any trouble, right? Then you go to the you go to that place, you face the east direction by checking the sunrise. Then when you are facing the east direction, your backside is going to show the west direction, and your right hand side is going to show the south, and your left hand side is going to show what? The north direction. Okay, so this is how you identify the main directions, my dear children. Right then, so as you can see here now, right, the buildings and tall trees can be used to find the directions at night. When you are watching the night sky, right, when you are watching the night sky, my dear children, so I told you that we need to identify the directions now, right? So you can, like by checking at that thing, right, by checking the whole area, you can point out a certain tree or else a building on a particular direction. Now let's imagine that there is a certain tall tower at the west direction. So you can point or you can memorize that certain tower. You know that you are going to visit that place on a daytime. So I am facing now the east direction. So from my right hand side, let's imagine that there is a tower, a tall signal tower. Then my dear children, I can decide that my right hand side, you know that my right hand side is going to show south. So at that place, in the south direction, there is a tall signal tower. Okay, so you can select these special landscapes or else like special signs, special buildings, trees, in order to point out a certain direction during the daytime. Then when you are going to visit that same place on the night time period, that position or that object is not going to change, no. So when I am visiting that same place during the night time, the tall signal tower is at the south direction. So always that tall signal tower is at the south direction, then the opposite direction is the north, right? So by identifying north and south, you can identify the other directions as well. So you can select a certain landscape, and from that landscape you can select a certain type of a special object or else a special kind of a construction, like a signal tower, a tall building, sometimes even big trees. So by that point, you can memorize the direction which is going to show. So that's how we can find out the directions, my dear children. Okay, so it's important to note out these directions. Why is that? Because I told you that these constellations are going to observe, or they are going to visible at a certain place on a certain direction. Okay, so you have to observe that particular direction in order to observe this particular constellation. It's really important to know. So it's really important to know the directions during the night time period when you are observing the constellations. Okay, right then. So tall buildings and tall trees can be used to find the directions at night when you are watching the night sky. The directions you identify in the daytime will help you in this regard. So like I said, my dear children, the directions that we are going to identify during the daytime period is going to help during the night time period also. So in that landscape, what you have to do, you have to select a certain type of a building or else a tall tree or else a signal tower, whatever. Then by that way, you can select the other directions as well. For a particular direction, you point out a certain special kind of a construction or else a tree or whatever, right? So by that way, we can identify the others as well. So remember, when you are observing or when you are selecting a certain landscape to observe the constellations, that landscape should be without any obstacles. When you look at the sky like this, so around the landscape or around that place, my dear children, there should not be any obstacle. Means branches of the tree should not be there, right? Then any other obstacles should not be there. You should be able to see whole 360 degrees of sky without any obstacle. So you have to select a place like that first. Then when selecting, it's better to select top of a certain mountain. That would be great. Or else you can select the topmost floor of your house. Or else you can select the roof of your house. Okay, or the topmost level of a certain building, right? So you can select these places. However, whatever the place that you are selecting should be without any obstacles. Remember it. Okay. Then we identify the directions. So how do you identify the directions? You visit the place during a daytime, right? Then by looking at the position of the sun, you can decide the directions. Then using a particular construction or else a tree or any kind of an object, you need to point out a certain direction. Then you visit the same place on the night time. Then by looking at that particular object, you decide the directions. Then by that way, you can check the sky in order to identify the constellations. Okay, right then. So here it is given, in the night sky, we see all the stars other than one star apparently move from east to the west. Now, in the night sky, we see all the stars other than one star apparently move from east to the west. So apparently, right, when you check the time day by day, when you go and check these stars or constellations, my dear children, apparently we can see that stars are going to move from east to the west. Okay, from east to the west, these stars are going to move. So like I said, if this is the east, if my backside is the west, you can see that the stars are moving like this. Okay, from time to time, from a particular day to another day, what will happen? These stars are going to change the position and move towards the west direction from east. Okay, so apparently this is what we see, my dear children. Apparently these are going to move from east to west, each and every star. However, my dear children, there is one exception. Okay, so there is one star. See, one star is not moving. So my dear children, here there is one particular star. Remember that there is one particular star which the position is not going to change. But however, all the other stars, apparently they are moving from east to the west direction, like our sun. Okay, it is given that, but actually what happens is that the earth rotates from west to the east direction. So earth is rotating from west to east direction. Okay, that's why we can see that the positions of the other stars are going to move from east to the west. It's like a moving bus. Okay, let's imagine that you are in a moving bus. Now the bus is going forward. When the bus is going to move forward, you can observe that the objects which are around you at the outer environment, those objects are going to move backward. Actually, what happens is those objects are stationary, but you are moving forward. So that's why you can observe that those objects are moving backwards. Okay, the same procedure or the same scenario is observed here also. When the Earth is going to rotate from west to east, the objects or these stars, celestial objects, are visible to us in the opposite movement. So if the Earth is going to move from west to east, my dear children, of course we can see these celestial objects which are going to move from at where? From east to the west direction. It is identical to the scenario of a moving bus. Okay, right then. So here it is given, the star that does not change the position is the Polaris. The position of Polaris does not change because it is located in the in line with the axis of the Earth. So the Polaris is a special star. I told you that there is one star which the position is not going to change at all. So that particular star is the Polaris. So the position of Polaris is not going to change because, my dear children, what's the reason? Because it is located in line with the axis of the Earth. Located in line with the axis of the Earth. So when you take the planet Earth, let's imagine that it is going to rotate like this. So when it is rotating like this, my dear children, if there is a certain object along the rotational axis of the Earth, if there is a certain object like this along the rotational axis of the Earth, so that certain object is not going to change the position even though the Earth is spinning or Earth is rotating. So this particular star is called the Polaris. Okay, this particular star is the one which is called as Polaris. So the position of Polaris is not going to change because it is on the, or it is in line with the axis of the rotational axis of the Earth. Okay, right. So within the figure here you can observe that star, the Polaris. Okay, so this is Polaris, this particular star. So the position of Polaris is not going to change. Okay, all the other stars are apparently observed or apparently seen moving from east to west direction. Okay, like the sun. But however, this Polaris star is not going to move. It is going to be stationary from one particular day to another. Okay, the position is not going to change even though the position of other stars are going to change. Right? So this is the specialty of Polaris, my dear children. Okay, right then. So you are given with a point. So this is a figure that we can observe. Right? This is a certain figure that about the stars, that star patterns that we can observe. So here it shows some constellations that can be seen in February to March. Okay, February to March in the sky about 8 p.m. during the night. So from February to March at about 8 p.m. you can observe these particular stars, my dear children. Star patterns actually. Right? So these star patterns are given here with their certain, right, imaginary figure, as you can see here, right? So at the northern horizon, there are twins like this, and the Taurus constellation like this, Pleiades like this, then the Orion or the Hunter, Canopus, then the Canis Major, right? So this is the eastern horizon, western horizon, southern and northern. So we'll be studying about these things. So just for now, we'll be studying about each of these star patterns in detail, my dear children. So up to now, you just observe the figures and get some idea how or what the location of these each and every constellation, right? So when you go further with the lesson, we'll be studying about these things further in detail, okay? Right then, so these constellations can be clearly visible during the months of February to March at about what? At about 8 p.m. my dear children, okay? At about 8 p.m. Right then, we see that all the stars in a constellation are in the same plane, but the distance to each star from Earth are greatly varying. The unit used to measure the distance between stars is light year. Light year. Light travels 300,000 kilometers per second. Light year is the distance that the light travels during an year, okay, during a year. So my dear children, what is the point given here? Now if you take the normal distances, we measure our normal distances. Distances means lengths, no? It's really simple. So the standard international unit of measuring a certain distance means a length, is the meters, right? Standard international unit of measuring distance is meters. So there are other different units like kilometers when you are measuring certain longer distances, right? So 1 meter is like this kind of a length, no? So when you are measuring the distance of certain two cities, it's very difficult to measure the distance or the length between two cities, as the two cities are much far away from each other. So we use a different unit called the kilometer. So kilometer is like thousands of these meter values. 1000 meters is equal to 1 kilometer. So you know these basic things, right? However, there is a special case like this. We see that all the stars in a constellation in the same plane, but the distance to each star from the Earth are greatly varying, right? Greatly varying. What do you mean by that? It means now when you check the star like this, and now you can see that the star is somewhat closer to you, like 10,000 to 20,000 of kilometers, okay? As you can see it, apparently we can see it like that, but however, my dear children, it's way more beyond that. It's way more beyond that. Actually, even we can't measure these things by kilometers. So we use a very special unit in measuring these distances from planet Earth to a particular star. We use different stars, there are different distances. The thing is that these distances are pretty much vary from each other, and they are also showing a very greater values. That's the issue. So we can't measure these things by kilometers or any other particular unit like meters. It's very difficult. It's because the distance. So I told you that when you are measuring length of a certain object, the international standard unit is the meters. We can measure the length of a certain table by using meters, breadth of a certain object by using meters or centimeters. Okay, but however, to measure the distance between two cities, we can't use the unit called meters, as the two cities are somewhat far away. In the same way, stars are very far away from us. So even the kilometer unit is not probable to use. So in that case, my dear children, we use the unit called light years. Light years. Okay. So now let me explain what do you mean by a light year. Okay. So I'll take the slide somewhat up. Light is a particular energy type. You know that light is a type of an energy. If you take the speed of light, right? The speed of light is a universal constant. So what do you mean by that? It means that when you take the speed of light, always light is going to travel at a certain particular speed. That speed is never going to change. It's a universal constant. No matter whatever the place, light is always traveling at a certain speed, and that speed is never changing. That's why it is referred as a universal constant. Normally, the speed of light is considered as this much. 300,000 kilometers. 300,000 kilometers within 1 second. Okay, within 1 second it is going to travel how much of kilometers? 300,000 kilometers. This is within 1 second of a time period. Okay, so what do you mean by a light year then? Light year means, my dear children, now let's imagine, now when you take this light second, this is called as light second. The distance that a particular light ray can travel within 1 second of a time period, it's equal to 300,000 kilometers. A very large value, right? Yes, extremely large value. Extremely large. 300,000 kilometers means 300,000, 3 lakhs of kilometers. 3 lakhs of kilometers. Right? Even when you take the distances, right? Distances between two towns, we can measure these distances as like 10 to 20 kilometers. Okay? If you take the whole, like Point Pedro to, so you take the, when you take our Sri Lanka, so from northern direction or from north, when you take a certain point and so at the topmost point, and the south direction also you take the topmost point, bottommost point. So that distance is also like around how much? Very less amount of kilometers, right? Very less. So however, when you take the distance that traveled by the light within 1 second of a time period, it's around 300,000. So it's very large value. So a light year means, my dear children, the time within a time of 1 year, the distance traveled by a particular light ray, that's equal to 1 light year. 1 light year. So let's see a certain calculation for this thing. This is the distance that a certain light ray is going to travel within 1 second of a time period. So if you are going to check this thing for a 60-second time period, then you have to multiply this side by how much? 60. You have to multiply this thing by 60, right? For 1 second, if it is moving 300,000, then for 60 seconds, this much. 60 seconds means you know that it is equal to 1 minute. So to convert this thing into hours, for 1 hour, we need to multiply again this one by, you know that there are, for 1 hour, there are 60 minutes. So the distance traveled by a particular light ray within 1 hour of a time period, what do you have to do? Once again, you have to multiply this thing by again 60. So this is within 1 minute of a time. This is from 1 hour. This is for 1 hour of a time. So within 1 hour of a time period, it's traveling 300,000 into 60 into 60. Okay, 300,000 into 60 into 60. So this is for 1 hour. Now let's go for a one particular day. 1 day. So in a 1 day, there are 24 hours. So once again, what do you have to do? Once again, you have to multiply this thing by 24. This is for 24 hours or else for a day. Finally, when you multiply this value again by 365 nearly, you can get 1 year. So this is the distance traveled by a particular light ray in kilometers during 1 year of a time period. Okay, during 1 year of a time period. Within 1 second, it's going to travel 300,000. So within 60 seconds or within 1 minute, it's going to travel 300,000 times 60. Within 1 hour, that means again you need to multiply this thing by 60. So 300,000 into 60 into 60 within 1 hour. Then within 1 day, there are 24 hours for a day. So you multiply again 300,000 into 60 into 60 into 24 within 1 day. Within 1 year, then you need to again multiply this one by 365. So even you can't calculate by using a calculator at least. You won't be able to write this thing as a certain value. So there are like millions, trillions of kilometers within 1 light year. So that's why I told you that we can't measure these distances by using kilometers, my dear children. It's not probable. Huge values of kilometers are coming when you are measuring distances between two stars. Oh, when you are measuring distance from our planet Earth to the particular star. Okay, huge values. So 1 light year is also trillions and millions of kilometers. So it's very difficult to measure these values, my dear children, by using kilometers. That is why we are using the unit called light years in order to measure the distance between two stars or from our planet Earth to a particular star. Okay. So to give you a certain idea, if you take the sun, a particular light ray which is going to escape from the surface of the sun will take about 8 minutes to reach the planet Earth. Okay, to reach the planet Earth, a particular light ray is going to take 8 minutes. So imagine the distance between the sun and our planet Earth. Even though the light is passing, or even though the light is speeding at 300,000 kilometers within 1 second of a time period, it's going to take 8 minutes, about 8 minutes to travel from sun to our planet Earth. So distance from sun to planet Earth is like, this is for 1 minute, no? This much. 300,000 into 16 to again 8. That's the distance from sun to planet Earth. So when you are discussing the distances between these celestial objects, my dear children, huge values are coming. So it's not probable to use these kilometer values. That's why we use the unit called light years, light days, light hours, and so on. So this is a brief about how we measure the distance between particular celestial objects. Okay, right, my dear children. So this is about the light year. So remember, we use this light year thing to measure the distance between particular stars. It's because that these stars are pretty much far away from us, right? Although the other celestial objects, right, and also the other celestial objects, my dear children, they are the same. These are also the same, right? Not only the sun, but also other celestial objects. Those are also the same. Remember it. Right then. So the constellation Orion and the distances to some stars of it from the Earth are given in figures. So as you can see here, this is the Orion, constellation Orion, right? So from Orion, right, so from planet Earth, my dear children, to each of the star in Orion are given with the distances. So here, from this place, that means this is the planet Earth, to this particular area is about how much? Thousands of light years. There are about thousands of light years. So my dear children, as you can see here, these stars are way more far. I mean, like, we can't even imagine the distance between planet Earth to these particular stars in kilometers. So kilometers is the largest particular distance measure in unit that we know. So even from kilometers, we can't take these things. There are about 1,000 light years, my dear children, from here to here. 1,000 light years. So that particular star is way more 1,000 light years. So it's a huge distance. Even though we can observe these stars, right? Even though we observe these stars twinkling all around us during the night sky or at the night sky, these stars are pretty much away from us. So the light which is coming from those stars, now let's imagine that I am looking at a particular star. Now when I am looking at a particular star, I can see that the light is going, a type of a light is going to emit from that star, no? So my dear children, if we assume that a particular star is 10 light years away from us, how much light years? 10 light years. So I can draw it by using a figure like this. Alright, I'll use the same one here. So let's imagine that there is a person on planet Earth and there is another star in this kind of a position. Let's imagine that the distance between this particular star, distance between this particular star to the person over here is equal to 10 light years. 10 light years. So now you know that this particular star is going to emit a certain light and that light can be observed by this particular person. But however, if you take the origin of that light rays, those light rays were emitted by that particular star 10 years back. 10 years back. So we are observing these light rays which are sent from that particular star 10 years back. I can explain it to you like by giving a certain example. We'll imagine that a particular light ray is coming from this star on year 2010. On year 2010. Then if you are observing from here, the same light ray is visible to this person, not on 2010, on 2020. Because that particular light ray is going to travel 10 years to reach that particular person. 10 years. That's why it is mentioned as 10 light years. 10 light years. So almost all the light rays that we are observing from here, from planet Earth, which are coming from each and every star, are way more older. Way more older. Even we don't know when we are checking from here, at this moment, we don't know that particular star is at that place or not even. Because we observe all the light rays which are received from those things. Okay. So my dear children, this is the wonder of our universe. Right? This is the wonder of our universe. Let's imagine that the sun is going to disappear suddenly from our universe. What will happen? You can observe the sun rays still for about 8 minutes. Why is that? Because the light rays which are coming from the sun will going to take around 8 minutes to reach planet Earth. So for about 8 minutes, even though now let's imagine that suddenly the sun is going to disappear from our sky. Even though the sun is going to disappear, you can feel the sunlight for about 8 minutes. Yes, it's because the light rays which are emitted at the moment which the sun is going to disappear will take 8 minutes to reach planet Earth. So we can see these light rays for about 8 minutes. In simple, let's imagine that the sun is going to disappear at 8:10 in the morning. Then for us, it's going to disappear at 8:18, not at 8:10. There is a gap of 8 minutes, about 8 minutes. Okay, not exactly, but about 8 minutes. So let's imagine that this particular star is going to disappear at 2010 AD. Okay, on the year 2010, this particular star is going to disappear from that place. Then we will be able to observe that thing on 2020. It's because the distance between this place to this place is about 10 light years. Okay, so this is the wonder of our universe. Each and every celestial object, each and every light ray emitted by these celestial objects are emitted way more beyond our timeline or our time level. Okay, my dear children. So these things are very interesting. Exploration of universe, these constellations, stars, these things are very interesting. It's like these things are being traveled with the time, right? Through the time, right? So it's very interesting, my dear children, to learn about these things. So this is about the light years and how to measure the distance between two stars, my dear children. So let's move on with the other contents. So the constellation Orion is given with many other names. So you are given with an assignment. So I told you that Orion, right? Orion is a constellation that we can observe during the February time period to March time period at about 8 p.m. So Orion is given with different other names also. So you have to find out these names, my dear children. Okay, so if you go back for the previous ones, once again, I can show it to you. So here you can observe that Orion constellation. So this is Orion. Okay, this is Orion. So during the February-March time period, about 8 p.m., you can observe the Orion. So this is that constellation, my dear children, the Orion. Okay, so you go for the pattern like this, you go for the pattern like this when you are observing the night sky during February to March time period. So this is the Orion constellation. Okay, so what do you have to do for this Orion constellation? You have to find out what are the other names given, and you have to collect these other names. I'll give you just one. Orion is also called as the hunter. Let me give you another name. Okay, during the medieval time, Muslim people, they were also observing about this Orion, and they were given with a special name called the giant. Okay, giant. So these are two different names given to Orion. Okay, Orion, right? You find out other names also. So Orion is in the shape of a hunter, right? In the shape of a hunter. That's why it is referred as the hunter, right? So my dear children, what do you have to do? You have to find out several information regarding the Orion. Okay, then find out these details, find out other names, and also try to get some idea, try to find out other special key points related to the Orion. If you refer the internet, you can find out several other names and several other information regarding the Orion. Okay, right then. The constellation Canis Major can be found close by to Orion. The brightest star in the night sky, Sirius, is found in this. Now Sirius is the brightest star in the night sky is the Sirius. Okay, so let me ask you a simple question. What is the brightest star that is visible to planet Earth? What is the brightest star which is visible to planet Earth? The brightest star. So the brightest star which is visible to planet Earth is not Sirius. That's the brightest star which is which can be observed from planet Earth, or which is observable for planet Earth during the night time period. Okay, at the night time period we can observe the brightest star as the Sirius. But I'm just asking about the brightest star which is visible to planet Earth, not about the planet. This is not regarding about the night sky. When you take daytime or nighttime, whatever, what is the brightest star that can be observed in planet Earth? So it's not Sirius, my dear children, it's sun. Our sun is also a star, right? Stars are the objects that can generate their own light. So our sun is also a star, my dear children. Remember that. Our sun is also a star. So that's why it can emit this much amount of energy, okay, from the nuclear explosions, from the nuclear reactions which are going to occur within the sun. This much of energy is given out to planet Earth, not for the planet Earth but for the other planets in our solar system. Okay, so each and every star is going to generate light energy like this from the nuclear reactions. So the closest star to our planet Earth is the sun, and the brightest star which is visible to planet Earth is also the sun. Okay, but these things change during the night time period, my dear children. Okay, you remember it. So the brightest star during the night time period is the Sirius. Okay, Sirius. So Sirius is located within a special constellation called the Canis Major. So Canis Major is somewhat closer to the Orion. See, this is Orion. This is Canis Major. Okay, this is Orion, this is Canis Major. Closer to Orion, you can observe the Canis Major. So this is the Canis Major, my dear children. So this is that brightest star which is Sirius, located on the Canis Major. So it is a shape of a dog. Okay, Canis Major you can observe in a shape of a dog. Actually, when you join these straight lines, for we can't observe exactly a dog within these shapes, my dear children. But however, ancient people given with these things, given with these names, while looking at a certain shape, so they have observed that the shape is like a dog. Okay, so this is Canis Major. Canis Major. This is also called as great dog. Okay, great dog. This Canis Major. So within the Canis Major, we can observe the Sirius, which is the brightest star in the night sky. In the night sky, remember. Okay. So when you are learning about constellations, it is not sufficient to study the diagrams in this book. It is essential to observe the night sky for constellations. The book is only a guideline for that purpose. Now, it's very important to observe these constellations, my dear children. So when the time comes, during, you know that there is a particular time region, time interval, which you have to observe these constellations, right? So when this particular time comes, my dear children, it's very important to observe these things, right? The book is just giving out a guide when observing these constellations. So by looking at the book, you can check the shape of the constellation, and you can refer for the same shape of the star pattern within the night sky, my dear children, during the particular time period. By that way, you can select the particular star pattern on the night sky. Okay, so that's how to observe these constellations. Actually, here the book is giving out a certain guideline in order to observe and in order to identify the particular constellation. But it is very important to identify these things during the night sky by your naked eye, my dear children. Don't look at these things just from your book. Okay? Don't look at these things just from your book. It's important to identify these things or study about these things by looking at the night sky as well. By that way only you can get a good experience about the constellation. So it's very important to observe these things on that particular time period by using or by referring the book, right? Okay then. So this is about the Canis Major. Okay, Canis Major. Remember, the Canis Major has the brightest star in the night sky, which is called as the Sirius. Okay, Canis Major. This is also called as the Great Dog. So Canis Major is in a shape of a dog, right? So Canis Major is somewhat near to which one? Orion. Orion constellation. Right. Then, if you observe towards northeast from Orion, if you observe, so this is Orion, no? So we have to observe northeast, right? Northeast from Orion. Another constellation, Gemini, can be found. So this is northern horizon, this is eastern horizon. So this is the direction northeast. So along the northeast direction, you can observe this particular star pattern, which is called as Gemini. So it denotes twins. So it is showing a shape of a twin brothers, right? Twins, like this. The brightest star in it is Pollux. So Pollux is the brightest star which is located on the Gemini constellation. So Gemini is going to show the twins. So this constellation can be observed at the northeastern direction from Orion. Okay, from Orion you can observe at the northeast direction the Gemini. So it's indicating twins, right? Twins, like this. So the brightest star which can be observed in this particular constellation twins is the what? Pollux. Pollux, right? So here you can observe the twins, the shape of the constellation. This is Orion and this is the direction northeast, right? So this is the shape of the constellation, my dear children, right? So remember, from Orion at the northeastern direction, you can observe another constellation called Gemini or the twins. So the next thing is the brightest star which is contained within this constellation is the Pollux, right? Okay then. So at this time, the constellation Taurus can be seen in the northwest direction, and there is a red star named Aldebaran for one of this bull's eyes. So here in the northwestern direction, my dear children, northwestern direction. So at the northwestern direction, you can observe another constellation called Taurus. Taurus, right? So this is that constellation, my dear children, Taurus. Taurus. So there is a red star named Aldebaran for the one eye. See, for a one eye of the bull, right? Or the ox. There is another star called Aldebaran. It is a red star. Okay, it is a red star. So this is the constellation Taurus. Okay, Taurus. This is the constellation Taurus. And this is that Aldebaran star which we can observe as one eye for the Taurus constellation. Right? Actually, this eye is going to represent the bull's eye. Okay, bull or the ox. This is in a shape of a bull or else an ox. Okay, so Aldebaran can be observed as one eye for the particular constellations. Okay, but for the particular, when you take the shape of the constellation, it is in the shape of an ox. So that ox has an eye. That eye is the star called Aldebaran, a red star. So the Taurus constellation can be observed within the northwestern direction. Okay. There is another special point which is given here, my dear children. See, near the Taurus, there is another constellation named Pleiades. Right, Pleiades. So near the Taurus, there is another constellation called Pleiades. Actually, these stars can be observed as like a bunch of stars. Okay, bunch of stars which is very closer to each other. It's like the heart of the ox. Okay, it's like the heart of the ox. Very closer to the Taurus. Very closer to the ox. You can observe the Pleiades constellation. Very closer. And these are bunched stars like this. Okay. Bunched stars. Pleiades. Right. It's like the heart of the ox. So these are several constellations that we can observe during the time period, my dear children. Right. During this time period. These are the constellations that we can observe in our night sky. Right. So we studied about several constellations. So we first of all studied about the Orion. Right. Orion. Then we studied about the Canis Major. So even we discussed that Canis Major contains the brightest star, right, which is the Sirius. Then we studied about the Gemini, the twins, and finally we studied about the Taurus. And I told you that very near to Taurus we can observe another special like bunch of stars. Okay, Pleiades. It's like it's representing the heart of the ox. So if you take the shapes, Orion is kind of it's showing kind of a hunter. Canis Major is showing a shape of a dog, right? Shape of a dog. Then the Gemini is showing twins, and finally the Taurus is showing the ox, shape of a ox or else a bull, right? This Pleiades constellation, it's showing like the heart of the ox. Okay, heart of the ox. So these are the particular constellations that we are going to observe during the time period, my dear children, during that time period. Okay. So from these particular 4 star patterns, my dear children, which we have identified, like 1, 2, 3, 4, actually there are 5. I told you that these things are very near to each other, so we can consider this is like a part of the Taurus. So from these 5 constellations, we'll be finishing the first chapter related to the constellation. So there is another time period. Within that time period, we can observe several other constellations as well. But however, my dear children, we'll be discussing about those constellations within our next chapter. Okay. So within our next chapter, we'll discuss about those special kind of constellations which we can observe during the other time period. Okay. Right. Then I'll be meeting you with the next chapter to discuss those constellations, my dear children.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.